Welcome to today's webinar, hosted by the Enviro Pet Waste Network, a nonprofit connecting people all over the world who want to share information and experiences of eco-friendly programs to manage pet waste. Everybody, except of course Rosalind, please mute your microphone so that there's no reverberation. Chat will be open throughout the presentation for your written questions, and the speaker will reply to your chat questions and be available for discussion at the conclusion. If you're joining us at the end, unmute your microphone. This webinar is being recorded. It'll be emailed to everyone who signed in for the webinar. Transcribed chat notes will also be posted. Our co-host is Richard Freudenberger of Living Web Farms, who has hands-on experience with anaerobic digestion and composting processes. Richard will help by monitoring the chat, and he may step in to add some comments during the presentation. His contact information is above on the chat if you'd like to get in touch with him. So Rosalind, change the slide and you'll be introduced by Richard.
Okay. So let's get started.
Yeah, well, I don't see the slide. Okay. So
no,
today we're
just change the slide, Rosalind. Next slide.
Okay, here we go.
There you go. Okay.
Okay, so today we're taking a look at an experimental process that Ruslan has developed, turning dog poop into organic fertilizer using an anaerobic digestion process plus worm composting, red wiggler worm composting. The webinar will be presented by Ruslan Zayarka, who is coming to us from Moscow, Russia. Ruslan graduated from Russian State University of Humanitarians with bachelor's and master's degrees in economics. For 9 years, he played professional football, which we call soccer in the United States. At the same time, he was a small business operator operating a sports nutrition shop. 2 years before the end of his football career, he developed the project that you'll be hearing about now. He incorporated as Benefit Limited, named for his two Pomeranian dogs, Benjamin and Fedor. His long-term goal is to establish an eco-business, repurposing dog poop into a safe and productive organic fertilizer. So now start your presentation there, Ruslan.
Yeah, again, so hello, everyone. Thank you, Richard. Thank you, Rose. So let's get started with the project. So the Benefit Ltd is a turning dog poop into organic fertilizer through the process of anaerobic digestion. We'll call it AD further, and plus worm composting. So the actuality of our project is that in Russia, dog poop is the force hazard class, and it's
there it is. Thank you very much. You're welcome.
So we have in our country several kind of discard problem, and each city has the own system of divide and discard. So in Moscow, for example, one part can be recycled and the other part not. And so that way dog's poop goes to the second group, and when our owners clean after dogs, they usually put there into the plastic bag, and secondly they throw it as an recycled discard, and finally plastic bag and poop ends up in the dump. And so that causes gas emission and soil damage, and that's the discard problem we want to solve. So, and what was our decision? It was the technology of anaerobic digestion, which is an oxygen-free process which converts dog poop into organic fertilizer. And the next slides I will tell about more about production, but to begin with the forms or fractions of the fertilizer we've made from dog poop is the liquid form, the solid form, and the third form is a biohumus, like a vermicompost. So the picture you can see from the left side is a tank for the process of anaerobic digestion. So some indicators about the tank, methane tank, or we also call it bioreactor, is the smallest commercial equipment for AD. Actually, it's really small because the amount it's actually 0.5 cubic meters with the material metal ST3 and insulation about 10 millimeters. It's absolutely fine. It can be worked, but it was made for small farmers or the laboratories for us. It's not popular still, but it's absolutely fine. It can be used as we used it, and so the temperature modes, right? We've used the 2 temperature modes. The first one is the 122, and the second one is the 148. It's like one of the most prolonged period of this mode, and the whole digestion period for both modes is 21 days. So the 21 days of anaerobic digestion with the composition of fertilizer 50 water, 50 dog poop. And that was the story that dog poop we collected in the shelter in Moscow, and we've tried and we've calculated the amount of poop produced by each dog. So yeah, it's only the only one friendly shelter which really allows us to make it. So I've moved it on my own car to the laboratory where we've made the next 2 pictures. You can see from the left side, you can see on the far screen the bioreactor, the tank, and the first picture here is a slurry, is a water poop mix in this tray. We've made the composition with water and poop. Just imagine the smell now. Yeah, just imagine it was a little house. It was really an awful smell, but that's the period, like a pre-AD mix, and then the period of digestion, and afterwards in the same slurry we've put the net. Here you can see the net. It's like a gray or a bit black colored. It goes through this net, and the solid fraction stay on the net. And afterwards we put it to the worm farm. In Russia, the story has no answer, but we call the California worm, red worm. We call it California worm. The scientific name is here. You can see Icenia foetida, and worm farm. It goes to the worm farm. So next, as a result, we have 3 fractions: is the liquid one, next solid, and biohumus. Actually, the difference I wanted to underline the difference with these worms on the pictures with biohumus, because fractions, they are almost similar, with the exception of the smell. The biohumus has the very big advantage because it almost has the specific smell from the fertilizer. It's almost the soil. And icing on a cake, it was the laboratory test from our experiment. It took about 1 year at all, the whole experiment. And here are the laboratory results. Actually, there are 27 tested indicators in each fractions. We've tested it by a certificated laboratory, the governmental laboratory, the biggest one and the most famous one. So they've made this. Investigations. So the liquid form, solid, biohumus, you can see the pH, the NPK numbers, the mass fraction of dry matter. And of course, I can share with you with all the interest parties by email. If you need it, you can just contact me and I will send it to you. But it will be on Russian language. That's the PDF files, so it is on Russian. And one of the most important indicators are the microbiology, and it's really like a honor of our experiment because the microbiology is clear, and we've checked the most checkable microbiology indicators here. It's six indicators, and the most important heavy metal content. And the results were such were on such level that we can actually use it in any kind of agricultural, including vegetables. Of course, I say it through the Russian regulations on pathogens and heavy metals, and it can differ according to your location. So it's what is acceptable in our country can really differ to your home. So you should check it. You should check the numbers, or maybe it's the same, but still. So and of course we need to check it on a more, maybe on tomatoes, etc. But still the numbers is really good.
Yeah.
And then we started testing our fertilizer, and to make this test more visible and to make it more clear, we've made 3 soil compositions. I've bought the cheapest soil in the common market just to buy the soil with less characteristics as I could, to see the difference and to see the advantage of our fertilizer. And so the first composition was soil TerraVita plus sand. Another one was with our solid fraction and biohumus, and another one was just an outdoor soil, actually in Moscow, in a big city. And look on the results. Here the testing. From the left side, you can see the parental ryegrass, and the first one was only watering by water, and I mean the ryegrass, and the Benfi where you can see the Benfi, it was watering by our fertilizer mix by 1:50, and so you can see the result. It's you can see that it's bigger, it works. And the coffee tree, you can see that coffee tree with water is set, and Benfi is better. So watering by our fertilizer shows better results. And not only visible results, we also had in the university, we've made the experiment. We had this dry machine, and we've made this calculation of a grass weight. And you can see the result also is about 25% better on Benfi. It's also a very good result. And concerning grass. And the last one, it was a funny story about the experiment. I've tried to make it outdoor in this block of apartment near to my home, and I just go outside and make this special places to ryegrass, and it's really looked like a grave, but it was not a grave. And one of walking woman was sort of scaring, and she came to me with this eyes of scare and fear. She was so afraid, but it was only the grass. And next we can see the result of this. Look here, also water and Benfi. Benfi is better with this watering is better, and watering, you can see the fraction of liquid fraction here from the right side. It's also the parental ryegrass, but it was seeded on outdoor. Yeah, and of course the anaerobic digestion is the biogas also production, and it wasn't our goal to measure biogas or to understand how it works. Our goal was to produce the fertilizer. So we've measured the over biogas and checked the process. So yes, it works. After 62 hours, methane started burning, and before the concentration was too low, and LEAP was around 3% in the first phase. and after 62 hours, concentration of methane was 30%. So like a conclusion, we prospectively can see that even on our dog poop with water, it can provide recycling in autonomous mode, prospectively, of course, and in bigger quantity of dog poop. And next, I want to say that we use the packs. We use this packs which are made from matter B. This is the material which is certified by Austria. It can be degradable and it can be used in anaerobic digestion. The picture on your screens is the tutorial to use it on anaerobic digestion from the matter B producers. Yeah, and we used it. Why we used it? I've tried to find the proper bag to collect the dog poop, because it can be promising in business way. So we used it, and our tests show that it can be used, but biodegradation is not perfect. We saw the little fraction of it. Maybe in bigger productions and with more expensive production, it will be degraded at all. But in our case, it wasn't the perfect one. And so I want to say some words about developing a business from this idea, and in what steps we've done. You can see already, but I will also say it, and what are our steps next. So the mission is to make dog poop into fertilizer, to collect and to recycle, to get the fertilizer. You can see the oats. It was out of my experiment, but I use this oats because I can buy it in any zoo market to my Pomeranian, and I try to seed it in my home, in my apartment, and to use the fertilizer. It also works, but it was out of my experiment. Just like an idea, it works also. So that oats with our benefit fertilizer, it was made. And moreover, I've done the special trash bin for dogs. It can be made from recycled plastic, but also, of course, it can be made by metal and by wood, etc. And a lot of technology nowadays are really affordable. But I want to be eco-conscious and to be more eco-oriented, and that's why I've used the recycled plastic. And I also made 2 constructive variations with this compartment and without back compartment. I wanted to make an idea and to come up with an idea to use it in different places, like in a closed hotel, for example, and in open spaces with bag or without bag. It depends. So like that. And for example, I've made calculations about the first production with this shelter, a friendly shelter I had, and they could collect it, and it's not a problem for them, and so so this cooperation is really affordable for everyone. And for example, they have at the moment 120 dogs, and my calculation was even more, that one dog produce more kilos of poo per year. But it's better to use less figures, and you can see that prospectively revenue per year can be $25,000. And yeah, I've made the American dollars here. The average market price, it's this is the price for this period of time and per liter. So of course it can differ, but in our country right now it is like that. Well, and nowadays, after the end, in the conclusion of our experiment, I've tried to get the permission to sell our fertilizer we can produce, and that was a big problem at the moment that I've got an answer from this from the administrative from the government like that, so that administrative barrier force us to find another way, because we need to certificate each our fraction, and it costs money. It needs time. For someone say that from 1 year to 2 years for each fraction, and of course each fraction should be financed. So it is a problem now, and now we and I am in particular, I want to find another way of developing our business and to develop this idea. So thank you for your attention. Thank you very much. Thank you. So I'm pleased you're here, and if you have any question, if you want to ask something, you're welcome. I'm here. Well, I'm waiting for you if you want to ask something.
Ruslan, this is Richard. I just wanted to add a little bit of information about my experience at the farm, our experience at the farm with our anaerobic digestion, and that's sort of how I came here, was because of that. Our goal was to produce gas. It was not to produce fertilizer. So it's a little bit different, but the end result is the same. And the problem is just because the liquid effluent, what you're calling the liquid portion, and also the solid material that's residue that's left, at least in the standards of the state I live in, and almost every state, is limited because of the bacteria that reside within the manure residue, even after it's digested. And that's why using the combination of the anaerobic digestion and the red worms is critical, because the red worms are very important to the decomposition of the bacteria and the toxins in the end result. We really we cannot apply the material directly to any soil on the surface, or to any vegetables, or even to fruit trees. It's not a legal possibility. The experiments we've done and other people at university have done here indicate that the residency time, the retention time within the composting system, and a combination of that and the temperature, is critical to get it to the point where it could be proven, as you've done here with your testing with the tester you used in Russia, that the temperature is required really up at the 66 degrees Celsius range, which is quite pushing 160 degrees Fahrenheit. And the residency time in some of our experiments, and also some of the contacts I made in my research, is up to 6 to 9 months. But that can be reduced with a higher temperature. So the hot composting technique on a small scale is really, really quite critical. So I guess what I'm saying is it's very doable. It's just that it has to be done carefully and with careful observation. And I'm sure, obviously you have done that, Ruslan, but I'm just thinking of people who might be watching this, or people who might be seeing it later, as it's recorded, thinking that if they do a little home setup, it might be nice to do, but it really has to be done carefully. And it has a lot of promise. I mean, I myself live in a rural area, so we don't have the dog waste problem. But in urban areas, it's a critical factor. And the other thing I found out in our research was dog waste dog and human waste are in their own sort of category. We use cow and horse manures for our experiments. Cat waste is one step even more toxic because of the toxoplasma that occurs in their feces. So just in case people were thinking about cats as well, that can be even another step of process. So anyway, that's all I wanted to add. I have been running a methane digester, an anaerobic digester, way back before 1990, briefly, and then now I've been using ours here I did a workshop about 2 years ago, and we've been running ours. Except I've stopped it now because we're rebuilding some of the containers. But anyway, that I just wanted to put that out there so people might be able to share that.
Yeah. Okay.
So, Ruslan, are you able to do any pathogenic analysis of your soils through, a university or somewhere nearby?
At the moment, no, I'm not able to do it because the project is like a closed, but the soil we used, it was bought unless the outdoor Moscow soil. So it was a clear soil, like a terameter soil. It was clear, but at the moment I cannot do it because the project is closed. It has financing. So
right. No, I appreciate that it takes effort, but that would probably address, Richard's points that he's bringing up with the fact that, there is the true value of assessing pathogens in the soil and making sure that, the process that you're developing has reached a certain thermodynamic threshold to mitigate what you're trying to do, because what you're trying to do is admirable and intelligent. And it's so fun to see that how you've done it on this scale and in your home and around your home, and like a real inquisitive scientist. But yeah, the pathogen piece is, I think, formidable to address, and then that would help you figure out if increasing your temperatures. But there is a lot of data out there on both anaerobic and aerobic, and thresholds that have to be met. So like here in the United States, we have natural reduction processes that are legal now for human remains, not waste, but actual human bodies. And so I think those might be some good guiding thresholds if we can get those to you to kind of see the temperature and the analysis pieces to kind of guide your next step if you go further and you open back up this experiment.
Yeah. And if I understood you right, so you mean to check the soil after using fertilizer, what will be the result of the soil, right?
Correct. Yeah, just that you're
aware.
Idea,
yeah. It's a really good idea. Yeah.
And the temperature threshold too. So you kept good track, at this level, but you might find even in a good literature research in Russia, the thresholds temperature wise that would be, ubiquitous across all microbial platforms for all types of decomposition to make sure that you're killing pathogens that would be byproducts of the waste.
Yeah. It's really a good idea. Yeah, thank you. Yeah, I hope we have this time. It's really aggressive.
Okay,
Shannon, if you have anything that you can send to Ruslan by email that would be helpful, that would be great.
Okay, yeah, if maybe get me his email, or I'll share mine.
Can you see the last slide right now, because it's on there?
Yes. Oh, so sorry.
It's okay.
Looking at your beautiful faces. Okay, I will send you something.
Yeah, thank you. Yeah.
Can you see the other questions? Can you see the other questions, Richard, on chat yet?
No, I only can see I can only see the one that that I sent to you. I'm sending directly to you.
Okay.
Direct message. I'm not sure if I can
I can see a hand. I can see a hand on mic, right?
Yeah.
It's a hand.
Yeah, Mike has a question.
Okay.
Hey, Ruslan.
Mike said,
I'm
go on.
mobile. I hope you don't mind. I'm talking mobile, but I'm sort of hands-free and I'm cruising, so I'm safe. I hope you can hear me and see me.
Yeah, hope you're safe.
Yeah, good. My question is on scalability. Like how are your thoughts on scaling this? I mean, is this something you want to introduce to the public realm, or is this some kind of closed market?
So I've heard only about the
So,
I heard about the scale to make this production really big one. It's not a problem at all. From the beginning, we can start with 2, maybe 3 shelter, because the shelter I cooperated is the smallest one, only 120 dogs. So it's not a problem to use with to cooperate with more. And for example, we have even dog hotels. It's also a big quantity of dog poop. So to scale this technology is not a problem. And even more.
I see a few problems, and I want to play a devil's advocate. Just so you know, as a business, I collect and divert probably more dog waste than I would wager anybody in North America from landfill. And some of the major challenges, especially dealing with anaerobic processors, number one is the quality of dog waste as a feedstock is regarded as very low. So on a large scale processor, dog waste is not desirable. Number two, once you start getting into public dog waste, the reality of having compostable bags, even if they are compostable, becomes a challenge. It requires a lot of pre-processing technology. And a third, now especially when you're getting into shelters and dog hotels, is a question, have you considered, eliminating the pathogens is one thing, but when you have dogs that I call them, they're, for lack of a better term, they're sick with parasites in mass. My experience is public shelters, municipalities run problem. I'm dealing with, I'll give you an example. I have one specific large municipality that I service. It's an animal shelter, and they've identified a ringworm outbreak in the city. Right now, all the animal waste we collect for them has been going to a farm compost anaerobic system. They've been advised privately, off the books, to divert that for the time being to either landfill or incineration. So, so I'm curious as how your process would account for a, Giardiasis, ringworm, roundworm, whatever parasite that dog might have inside them when they make their stool. So those are 3 big challenges, and those are just 3 that I can think of right now. I could probably identify a couple more that you would have. So I'm wondering, like, what's your business game? How do you respond to those challenges?
Yeah, I will start with the second problem you've called. Yeah, with this the quality of dog poop, right? And from the public, it's really the big problem because of the content of the soil. Maybe there are some pathogens we cannot see, even from the gasoline, etc. But from the shelter, there is a problem with the cheapest food they've got, and they really buy the cheapest one. And still, as we could check it through the anaerobic digestion, all this the quality you could see on the slide with the laboratory results. The NPK is really quite enough. It can be measured like a good fertilizer. and the pathogens also on low level, and from the even microbiology and the heavy metal content. It is so. And on a big scale production, it won't be a problem. It won't be a problem.
Well, like I said, I'm diverting large, like I'm talking from this one location, about a ton every 2 weeks that were initially going to the anaerobic processor that were cut off because of the presence of roundworm. And these are dogs that were brought to the animal shelter from the public. It's you know, the speculation that it's a result of people not, you know, getting rid of their dogs because of COVID. I don't, you know, it's again, it's speculative, but it's a pretty good assumption. So, you know, I say that because in my experience, the anaerobic processors, if they have the ability to select what kind of input they get, dog waste is not high on their option list. They'd rather have higher quality feedstock. And I've also been, you know, the quality of the fertilizer that is produced from these other sources are much higher and can be sold at a lesser price. I don't mean to discourage. I'm just kind of trying to play some devil's advocate from the market, especially when you're getting into the large scale public sector market. So.
Yeah. I am in doubt about the difference in quality for example, from the cow manure or from the horse manure. I've made the comparing from the market fertilizer that we have here, and the numbers really are the same. So, but the result of this fertilizer, of course we need more testing. The ryegrass or coffee tree is not a big scale to test. Of course we have to do it, but the figures here and moreover, maybe it depends on the shelter. For example, in our country, the administrative barriers are really high, and maybe in this case, it's even better, because it's really hard to be dog shelter, because you need to provide dogs or cats with the medical, with all this with all the medicine, with everything, so they are healthy one. So maybe that's why we've got maybe the reason why we've got the good numbers, because of the composition 50-50, because as I know, in the biogas production, it's usually low concentration of this organic mass. Maybe that's the reason was.
Right. Yeah, that could be that sound correct. That makes sense. But it sounds like your solution, it would have to be this is my opinion, it would have to be directed for somebody or some place that wants to divert dog waste very specifically, and that becomes a challenge in mass, but it can be done. It can be done, but it requires, again, that effort of, I would suggest, segregating dog waste specifically. Again, do you have any experience with separating the dog waste? Like, how did you get into actually physically, like, how did you collect the dog waste, and how did you separate it?
You mean privately with my dogs, or you mean?
Okay, I understand. Okay.
Well, he got it from a shelter. He got it all from a shelter, and I think the pathogens were. He got rid of the pathogens through the vermicomposting, not necessarily the digesting. You think?
I would think a lot of the other contaminants, the toxins, were actually mitigated through the red worms as well. That's probably even more critical because people would be looking at things like lead and zinc and and high salinity and things like that. And the worms have a pretty good handle on that stuff.
Are the red worms effective at combating other parasites that the waste might have? Does anybody know?
Well, at the last webinar that we had a woman named Kathy Doskin, and she was doing hot composting followed by vermicomposting for dog waste. And the worms really killed pathogens. Nobody has cracked the whole thing of eggs, Helminth ova eggs, parasitic eggs. They've gotten a larva. Ruslan talked about larva, but nobody's done an experiment. What we need is academic input on this. Nobody's done an experiment to prove that either composting or biodigestion or vermicomposting of dog waste really gets rid of the ova of the larva.
Interesting. Okay.
Yeah, there is other challenge also with the red worms. The specific organic, the dog poop is a specific organic for them, for the red worms. They start to recycle it, but as we saw previously on just the from the organic discard, they started more faster. They faster do it, and with the dog poop, they really recycling it, but slower. So it's a new material. It's also a challenge. And of course, they need some populations, one second population, the third population. They will, you know, that they are they're really clever, so they can do it better and better. But it's also a challenge.
Thank you. Thank you.
Thank you.
And Mike, you had a question. How does this calculation compare to higher yielding fertilizers produced from anaerobic process sold at much lower price? Did we answer that?
That was more my a bit of a devil's advocate. I mean, if I'm a farmer, large scale, or if I'm having an agricultural process, I can find cheaper fertilizer, organic fertilizer. I mean, why? How does this? How does this compare? How does it, in your opinion?
So
I think one of the things that nobody knows about dog waste, which should be studied by a horticultural department somewhere, people who sell compost and sell soils to nurseries for specific things, like you want to have great roses or you want to have great dahlias or whatever. I mean, I think Ruslan talked about grasses, and we see that it does very well for grasses. It could be super for restoration areas. But one of the things we don't know is horticulturally what it grows best. If there's something about it that's very special, does it have special microbes in it that can be used like nothing else, and can be sold for that specific reason? If you want your daylilies to be wonderful, use this. There's no crossover between repurposing dog waste and horticultural value of it. And we've got so much dog waste, and nobody's trying to figure out what to do with it except put it in landfills where it makes methane. So that's my lecture.
Well, I'm with you. I think he's got to find the people or the places that are looking to target dog waste specifically, very specifically. And the problem is the problem exists, and there are a lot of places that are looking for this solution like this. So and I deal with some municipalities that refuse to go to incineration. So I mean, they're very adamant on an anaerobic on the biodigestion anaerobic process as a solution for their dog waste. So these places are out there.
Mhm. So there's a market for it. And we've got two people here who are researchers from universities. We've got Shannon at the Colorado School of Mines, and we've got Stephanie at the University of Maryland. Maybe at their universities, there's a department or, you know, someone who would do this as a capstone program, or, you know, as some sort of research project, because it really is needed considering how much dog waste we have and cat waste.